Alright, so today we're going to be learning about resultant vectors. And what are resultant vectors, you might ask? Well, a resultant vector is the vector sum of two or more vectors. So when you add two vectors together, you get a resultant vector. And so what this video is going to be talking about is how to do that exactly. But before we get into that, I'd like to just give a brief review of what a vector actually is. So I'm going to draw a nice Cartesian coordinate plane. Oops, sorry, Stuart. Alright. Just like this. And I'm going to draw the vector 3, 2. And so basically, when you draw the vector 3, 2, it indicates that a given object at the origin moves 3 over in the x direction and 2 up in the y direction. So your vector showing the displacement is going to look like this. Now, a vector is a measurement of displacement. And the thing you always have to remember with vectors is that it is from the beginning point of any given path to the ending point of any given path. So you probably have already noticed this, but right here I have this Lego figure. His name is Stuart. Wave hi, Stuart. Hi. And so Stuart's going to demonstrate this. So if Stuart starts at the beginning of the vector, he travels in here in all these weird ways. Regardless of where he travels, as long as he ends here, the vector describing his motion is 3, 2. If he went straight, it would be 3, 2. If he went up all the way over here, and then down over here, then around over here, it still would be 3, 2. Because at the end of the day, a vector measures it from the beginning to the end of a path. That's it. Just the displacement. And I'll just write that over here real quick. Displacement. So keeping that in mind, we're going to now talk about adding and subtracting vectors to get a resultant vector. Alright, so now that we know what a vector is, we can now add them and subtract them. Alright, so we're going to start with adding vectors. So let's just adding vectors. Alright? And there are two ways you can really use, two ways that you can use to do this. So if I had a problem like 1, 1 plus 2, 1, all right, we could solve it in two ways. The tip to tail method and you could just use a formula. And I'm going to go through both ways in this video here. Alright, so the tip to tail method is kind of like the graphic, like if you use a graph or just the geometrical way to think about it. Alright, so I'm going to draw a Cartesian coordinate plane here. I'm going to label my x and y axes. And so 1, 2, 3, 4. 1, 2, 3. That should be good for this problem. And what I'm going to do is I'm going to draw my first vector, 1, 1. Now, in the tip to tail method, what you can do is then you can attach your second vector onto the tip of the first one. So here's my tail end at the beginning, and I move over 2 and up 1, like that. All right? So here's my vector 1, 1, and here's my vector 2, 1. And what you can do with the tip to tail method is then you can say, okay, so you can take the starting point of the first vector and the ending point of the last vector that you've attached with tip to tail, and that right there, geometrically, that is your resultant vector. So your resultant vector in this case is 3, 2. Alright, so now you can just pretty much attach vectors tip to tail, and once you get the final, once you detach them all tip to tail, you can take it from the beginning all the way to the end. All right? So now this formula right here is also a nice handy way, and it's just kind of a manifestation of what the tip to tail method already does. So if I have a vector A and I add it to vector B, and these little hat things, that's how you represent vectors in math. You can represent A, and you represent A as A1, A2, and B as B1, B2. Adding them together, the resultant vector is equivalent to the sum of the x components, so A1 plus B1, plus the sum of the y components, A2 plus B2. So if I use this formula here, and I have the vectors 1, 1 plus 2, 1, what you get is 1 plus 2, so this is summing your x components, and then 1 plus 1, and that's summing your y components to get the vector 3, 2. So these two ways are are the two ways that you can use to add vectors together. This is kind of more visual way of doing it, and this is kind of just more of a brute force more algebraic looking method. This just has a little formula to it that's can be simpler for some people. So these are really the two methods that you can use to add vectors together. All right, so you're using the tip to tail method, you're using the formula, and everything is going great, but all of a sudden you see a problem that looks like this. 1, 2 plus 1, negative 3. And you're looking at that and you're just like, oh no, this is horrible. But don't worry, you can still use the same two methods that I showed you. So if I were to use the tip to tail method with this problem, I'm going to draw a nice Cartesian coordinate plane, and like so. I'm going to label my axes like this. If I added some sound effects. What you have here, you can still use the tip to tail method. So I'm going to draw the first vector, 1, 2. So I'm going over 1, up 2, just like we have been doing, like that. And then what you do is you use the same second vector. So then what you do is you go over 1 and then down 3. So your second vector looks like that. Your resultant vector still is the beginning of the two vectors added together to the end of the two vectors added together, which looks like this. So your resultant vector, oops, just a little bit off, is 2, negative 1. Same thing, I'm just going to label this right here, tip to tail method. You can do the same thing using the formula, all right, which is A1, A2 plus B1, B2. These are just to represent the x and y components, equals A1 plus B1 and A2 plus B2. Boom, like that. All right, so now what you can do is, so you can take 1, 2 plus 1, negative 3, and add together the x and y components. So 1 plus 1, 2 plus negative 3. And then what you get is you get your final resultant vector, which is 2, because 1 plus 1 is 2, the x components of the 2. And then 2 plus negative 3, that's negative 1, which is exactly the same as what we got in the tip to tail method. So don't get afraid when you see negative values. You know, it's just, you can still use the same methods, and I just wanted to make that point clear before we moved on to our next topic, subtracting vectors. So now that you know how to add vectors together, what we're going to be doing now is we're going to be doing some subtracting with the vectors. So we're just going to subtract vectors. So we'll just say subtract vectors. Now, the thing is before you subtract vectors, you kind of have to turn it into an addition problem, all right? So let's say you have the problem 3, 1 minus 1, 2. Now, the thing is what you got to do is you got to rewrite it as an addition problem, all right? So with vectors, you can multiply it by a given scalar. So let's say multiply by 1, and it equals 1, 2. You can multiply it by 2, and you get 2, 4. Essentially, 1 times 2 for the x component is 2. 2 times 2 for the y component is 4. And you can also multiply it by negative numbers. So negative 1 times 1, 2 is equivalent to negative 1, negative 2, because you're multiplying the x component by negative 1 and the y component by negative 1 to get that. All right? So now, using this here, we can just rewrite this problem as 3, 1 minus 1 times 1, 2, and then rewrite it again, plus, all right, here, like that. All right, and this negative now is absorbed in this scalar. And so when you multiply it out, you get negative 1, negative 2, just like we have over here. And so now you've turned this subtraction problem into an addition problem, and you can use the same two methods, the tip to tail and just the regular formula that we used for addition. Okay? So now I'm going to draw a nice little Cartesian coordinate plane just to show you what I'm talking about. All right, so we'll have this here like this. And I'm going to label, oops, I'm going to extend this down just a tad. And what we're going to do is now we're just going to draw it out. So I'm going to label this here. All right. X and Y. All right, so our first vector here is 3, 1. So over 3, up 1. All right, and now what you do is you just add it tip to tail method. What's the second vector here? Negative 1, negative 2. So you go over negative 1, to the left 1, and down 2. So the second vector, attaching it tip to tail, right, is negative 1, negative 2, just like that. All right, and so your resultant vector is just the beginning of the vectors added tip to tail to the end of the vectors added tip to tail, just like this. And so your final resultant vector is 2, negative 1. And then you can also just use the formula. So you just add the x components together, 3 plus negative 1, and then 1 plus negative 2, and that is equivalent to 2, negative 1. And so that's just kind of a basic overview of how to subtract vectors. So hopefully now you know how to add and subtract vectors to the resultant vector. And if you have any questions, just write a comment below and I'll try to answer it.